started. We're going to continue to switch up the format this week. So on Tuesday, we had an external speaker giving our student colloquium. And so today, we have a local speaker giving our regular colloquium. So we switched up, the time and the order and the locality. So I'm very pleased to introduce you to Akira Omaki, who is a new faculty member in the Cognitive Science Department. So Akira comes to us from the University of Maryland, where he got his PhD in 2010. As a number of other people in the room also came from the University of Maryland, so we're very happy to have him here. And he works in psycholinguistics and language acquisition and theoretical linguistics. And he's actually coming to us after spending a year in Geneva doing a postdoc there. So everyone, please welcome to Akira to Johns Hopkins.
So I need to hold on.
If you could put this in your pocket. Put that to your collar, you should be good.
Like that. Okay. Okay, so thanks for inviting me over here. So yeah, as Adam said in the introduction, I'm so new here, and then that's why I was really lost on the way here. The Hackman Hole is not on the map for some reason. So it took me a while to find it. But anyway, so yeah, I'm really happy to be on this campus where there's lots of good theoretical linguistics research and psychology research, right, happening in cognitive science and PBS. And then there are lots of strong computationalists in this place. So, this is exciting for me because, that's exactly what I do. The interface of computational models of language processing and language acquisition is what I'm interested in. So I would love to have your feedback on my work. Okay? So in this talk, I'll be focusing on predictive processes in sentence processing, how that happens, and what kind of consequences that has on our sentence interpretation behaviors. So this is just to show that predictive processes seem to be very ubiquitous in our daily lives of cognitive processes. So I guess the domain in which this predictive behavior gets talked about most often is a motor planning literature. So this is, for example, a study by Lalonde and McLeod. So they were looking at visual fixation patterns of a cricket player. Okay, so he's a batsman, right? And then they studied eye movement patterns of good batsman and bad batsman. And then they found out that the good hitters tend to focus on the trajectory and the velocity of the ball before it bounces, right? And then that is sufficiently giving him to predict how the ball is going to bounce. And then that information is coming to the batter early enough such that the batter can sort of, program the motor movement pretty accurately and in time before the ball arrives. Okay. And when you also track eye movements of people who are making sandwiches, so this is a task in which they have to make a PB&J sandwich, and then you can see that before they try to actually reach, for example, towards the peanut butter, you can see that people are fixating on the peanut butter, identify the location of the target object, so that they can plan their arm movement much more accurately. Okay? And this type of predictive behavior seems to be happening in language processing. So this is a demonstration by Altman and Kamide. So for example, they presented a little scene like this where there's a picture of a boy, a cake, and a bunch of other toys. And they presented sentences like, the boy will eat, blah, blah, blah. And then what they found was that as soon as the listeners heard the verb eat, they sort of moved their fixation towards the cake, as if they predicted that the word cake was going to be mentioned later in the sentence. Okay? And this is certainly interesting evidence that this kind of predictive interpretation seems to be happening in language processing. But as a psycholinguist who tries to understand the actual algorithm that allows us to put together syntactic structures and assign interpretations, we want to understand the exact procedures that generate this kind of predictive behaviors, right? So as many of you know, sentence processing is a really multi-level processing task. So there are lots of linguistic representations that you need to coordinate. There's syntactic representation, semantic representation, and a lexical representation, right? I mean, which of these representations is causing such predictive behaviors? And then how exactly predictions can be generated at each level of linguistic representation? I mean, this is the kind of question that we need to answer in order to really understand how exactly sentence processing behaviors work. Okay? So one of the reasons why it's difficult to sort of disentangle which part of these representations is causing prediction is because these studies are looking at very local dependencies, right? You get the verb, and then that contains a lot of information, and then we're looking at predictive behaviors with respect to something that's coming up very closely, right? So one thing I'm going to try to do today is to look at how we process filial gap dependencies, okay? So if you have a sentence like the boy ate the cake, this is a syntactic representation for it. In English, you can have a construction like the cake that the boy ate, right? So here, what used to be the object is sort of dislocated to the left of the sentence, okay? And so yeah, we can sort of dissociate the object from the verb. So the parser's task when you're processing the sentence from left to right is to sort of associate this fronted element towards the verb so that we can assign a thematic interpretation, okay? And then by focusing on this construction, I'm going to argue that there are three sort of stages of processing, okay? The first stage is to identify this dislocated element called the filler, initiate the search process, and then you build a syntactic representation for this original thematic position, which we call a gap, okay? And then we can engage in semantic composition and discourse integration, okay? And I will present evidence from different kinds of eye-tracking techniques to argue for the existence of these three stages of processing, okay? So this is about how prediction happens, right? And another thing I will talk about is the functional significance of prediction, right? So, I mean, why do we even predict things in language processing? I mean, one thing is that it reduces processing burden, right? I mean, like I said, you need to be coordinating lexical, syntactic, and discourse representations simultaneously while you're processing upcoming materials in the later part of the sentence. So if you can sort of get rid of some of these processes ahead of time, that just allows you that gives you extra resources that you can use to attend to other things, right? And it also makes you robust against noise, right? I mean, if you can predict something is coming up, like, you know, if I say the boy ate the cake, or something like that, right? If I say it silently, or if there's lots of noise, and you might miss hearing the word cake, but if you had predicted that word, then you're not going to be bothered by the presence of the noise. At the same time, predictions could be wrong, right? Because, so in that context, right, the speaker could have said the boy will eat the toy, I mean, which is really unlikely, but something like that could be happening. And then it's been known that when you commit to a wrong analysis, a wrong interpretation, it takes a lot of effort to revise your interpretation and analysis. So prediction is really like a double-edged sword. But that somehow doesn't seem to prevent us from doing this kind of prediction, okay? So we look at how the consequences of prediction in detail. So for example, there's studies showing that adults and children seem to often get stuck on a wrong interpretation in a sentence like, while Anna dressed the baby, spit up on the bed, right? You're a little surprised when you hear this because you thought that the baby is the object of dress, but it turns out to be the baby, right? The baby turns out to be the subject of the next sentence, right? But if you ask adults how they interpreted this sentence, people often say the baby was actually the object of dress, okay? So this kind of misinterpretation seems to happen. And then by focusing on revision failures in WH processing, filial gap dependency processing, I will argue that the nature of representations that's being revised seems to predict how difficult it is to actually revise initial analysis. Okay? And also, another possible consequence of prediction is that this might mislead learners to learn the wrong grammar, for example. Okay, so this is like a rudimentary model of language acquisition, right? I mean, there has to be some sort of input that goes into children's heads, and then they sort of select the right grammar based on the input distribution. So, I mean, there are lots of sort of hypothesis testing happening in children's mind, let's say, but that hypothesis testing is sort of dependent on how we encode the experience itself, right? And if we find out that children are misanalyzing the input, then the information that feeds into this learning mechanism is also going to be, leading you to wrong generalizations as well, okay? So I will examine that part of filler gap dependency processing as well, okay? So that's the roadmap for today's talk. All right. So the first part of the talk, is focusing on how English speakers, adult English speakers, process filler gap dependencies. And that was done in collaboration with these people. Okay? So, well, I mean, so far, a lot of the research has shown that we are kind of very active in assigning interpretation to sentences, right? We don't wait until the end of the sentence to assign interpretations. We're very incremental. Word by word, we're calculating interpretations, right? But with respect to filler gap dependency processing, not much has been revealed except the fact that upon identifying the dislocated element, we start to initiate a search process for the gap position. Okay? So in order to actually look at the time course of filler gap interpretation, I use a method called the visual world paradigm, in which we're measuring sort of fixations in the scene while listening to linguistic stimuli. So this is the kind of experiment that Altman and Kamine did that I talked about earlier in the talk. Okay, and then so we sort of measure how visual attention shifts as a function of the sentences that they're comprehending. Okay. All right, so what we did was to present a little story. So, well, first on the computer monitor, there was like 5 objects, okay? And then we told a little story that Emily first ate the cake with a fork, and then she also washed the dishes with a sponge, okay? And then we asked questions like, can you tell me what Emily was eating the cake with? We also asked, can you tell me if Emily was eating the cake with the fork? So at the point of hearing eat, right, that doesn't necessarily tell you what object is coming up, right? So, I mean, as we saw earlier, verb information is very rich. So you could predict, looking towards that the cake is going to be mentioned later, okay? But it's also possible that in the WH context, right, you already have this object fronted towards the earlier part of the sentence. So at the point of eat, you might already associate eat with the WH phrase what, and then recall what happened in the story, and then look more towards the cake when you hear WH question, okay? As opposed to when you hear if Emily was eating the cake, right? At that point, the noun phrase, the cake, does not need to be mentioned in the story, okay? Okay. So let me just break down what kind of processes needs to go into that kind of predictive behaviors. So first, we need to recognize the verb, right? And then access the mental lexicon. And then you need to compose verb and what, right? And then recall what happened in the story, and then program your eye movement and execute, okay? And based on lexical access literature and psychophysics of eye movement, we know that these processes seem to take about 150 to 200 milliseconds. Okay, so altogether, we don't know how much these things take, but I mean, I guess we could reasonably expect that this might take about 600 milliseconds. Okay, and then this is plotting now the proportion of looks towards the cake. and the WH condition, which is the red line, and then the yes/no question condition, which is the if condition, right? That's in the black line here. And the time 0 is the verb onset. And then you can see that the looks towards the cake really diverge in the WH condition from the yes/no condition right around 500 milliseconds after the verb onset. Okay? Which suggests that it really took about 500 milliseconds to process the verb and recall what happened in the story and then initiate your eye movement. Okay? So this suggests that the interpretation and the sort of the referential mapping to the scene takes about 600 milliseconds, right? Okay. So there's also another related study in which people studied how we interpret WH phrases, right? WH questions. So this is a really similar study by Sussman and Sedevi. So they just, again, told a similar story. And then they asked, what did Jody squash the spider with? Okay? And compared that to, did Jody squash the spider with a shoe? And what they found, though, was that the divergence between WH and yes/no question conditions starts around 50 milliseconds after the verb onset. Okay? So it seems that in this study, somehow the interpretation process was happening much earlier. Okay? Which is really surprising given that there's a pretty robust evidence that shows that lexical access and eye movement programming and execution takes 400 milliseconds together, right? So this suggests that this early eye movement towards the spider in this context must have been programmed before they even heard the verb. Okay? And in this study, they actually had a much more sort of impoverished context provided to them, right? So I sort of skipped the story, but it was just really about Jody eating the breakfast and then saw a spider, so she just squashed it with the shoe. Okay. So and then they had many lines about how she was scared about spider and whatnot. So it seems to be sort of the story was sort of highlighting how important the spider was. Okay. So it's possible that in this kind of very restricted context, people can sort of generate expectations much earlier. Well, in other words, here, specifically, people are sort of expecting to hear about the squashing the spider event much earlier, even before they started hearing the verb. Okay. So you can see that how predictive process could be manipulated based on the amount of information that's provided to listeners. Okay. Okay. But what I'm going to try to argue is that even within that 600 milliseconds of interpretation, there's another distinctive stage in which we are just building syntactic structures without assigning any interpretations. Okay? Yes, sure.
Possible that there's something to do with the spider itself?
Oh.
It had something less interesting than
Yeah, this is just one story from the experiment, but they have many. Other stories. So yeah, it's true that the spider is very visually salient here. But yeah, in other stories, that was not a problem. Okay.
And you didn't observe anything similar with the stories about Emily, who did 2 different acts?
Yeah, exactly. And then, yeah, that was actually a crucial point of the study that I forgot to mention, because in that story, there were 2 equally salient events. So you couldn't have predicted which event was going to be mentioned, right? Which sort of forced listeners to listen to the verb and then initiate the eye movement. Okay. Whereas in this story context, there was really just one salient event, okay, and then therefore they were just able to predict what verb they were going to hear in the story. Okay. All right. So now, do we actually find evidence that there's even an earlier stage in which we're just building syntactic processing structures? Okay. So there have been lots of reading studies that seem to indicate the presence of such stages. So for example, there are studies by Traxler and Pickering, for example, in which they present sentences like, the book that the author wrote regularly about was on sale. Okay, so here the book is the object of the preposition about, right? But if you look at the sentence carefully, it's possible to analyze the book as the object of wrote temporarily, right? After you hear about, and then you see that this object is missing, you know that the book has to be coming from this position. But when you're reading from left to right, you don't know that this position is coming up. And then it seems that the parser is really actively creating this kind of gap, because when you look at the reading time for the verb wrote in a sentence like the book that the author wrote, and compare that to the city that the author wrote about, okay, you can see that the reaction time increases in the city condition compared to the book condition, which suggests that the parser really immediately associated the city with the verb wrote and analyzed it as an object. And you can't say wrote the city, and therefore you think that something is going wrong. Okay? So again, this shows that parser is actively searching for a gap. But this doesn't tell you at which point this active gap creation is happening. It could be that this is initiated after you process the verb, right? You process the verb and you say, wrote is a potential transitive verb, and therefore I'm going to associate it with this, the filler that needs to be assigned a thematic role. On the other hand, if you go to other languages like Japanese, for example, which is a head final language, so all the verbs come at the end of the sentence, right? So if you have a sentence like, who did John say that Bill sent a letter to, and translate it into Japanese, right? What you get is John at the beginning of the sentence, the main clause verb say at the very end of the sentence, and then the embedded clause goes in between, okay? And then notice that the first verb you see in the sentence is actually the embedded clause verb, okay? Unlike in English where you see the main clause verb first, okay? And then also the objects of these verbs come before the verb in Japanese, right? And then what people have shown is that there seems to be evidence that people are actually creating a gap for a fronted WH element like this even before they see any verb. And then that seems to be happening inside the embedded clause, okay? Which is presumably because this is really the first position in which you can assign a thematic role, right? The first verb you hear is the embedded clause verb, so why don't you just put that WH phrase into the embedded clause, okay? But so far there hasn't been very strong evidence that this kind of pre-verbal predictive behavior is happening in English, right? Okay, and despite the fact that it's not so crazy to do that, right? So if you process a sentence like, again, the city that the author wrote, you could imagine that at the point of processing the subject, and then this fronted object, the city that the author, right? You know based on the rules of grammar that there has to be a VP coming up, right? And if you know that VP can contain a noun phrase object position, then you could just, the parser could be such a risk taker and just commit to the NP object analysis even before the parser sees any verb, okay? So just to distinguish this from the regular active gap creation, I call this hyperactive gap creation, okay? So this is like a syntactic prediction process that is completely independent of bottom-up verb information, okay? And if the parser is engaged in such process, then you would expect that if the verb turns out to be transitive, the parser should be happy. But if the verb turns out to be intransitive, the parser should be annoyed, okay? So that's this kind of transitivity mismatch effect is what we predict if the parser is engaged in this kind of highly predictive syntactic structure building process. Okay? So we look at this by using an eye-track enduring reading technique in which we just measure like the fixation patterns through a text. Okay? And it usually goes like this. So you fix it on different words. Sometimes you go back, and sometimes you move forward. Okay? And then by summing these fixation patterns in different ways, we can sort of tap into early stages and late stages of sentence processing upon fixating on each word in the sentence. Okay? So we contrasted these two sentences by varying the type of the transitivity of the verb, right? The costume party that the student arrived for, the costume party that the student planned for, right? And then again, if you're engaged in such a early predictive structure building processes, then we expect that all we need to see in order to actually generate this error signal, right, is to just access the verb information, right? As soon as you access the verb, you know if it's transitive or intransitive. So at that point, you immediately know whether the structure prediction you made is right or wrong, okay? So in order to do that, all we need is just the first lexical access process that's happening upon fixating on the verb, right? And then that usually happens within a single fixation. So the critical dependent measure for us was to look at the first fixation duration on the verb region, okay? And then when you look at that, you can see that the intransitive verb condition was much longer than the transitive condition. But just comparing this, you might say that's just a difference in the lexical items. Okay, so we need a much better baseline condition. Right. And in order to do that, we created what's called a syntactic island environment. Okay, so let me just walk through that. So if you have a sentence like this, the author wrote regularly about, right? You can create a double-edged question out of this, right? What did the author write regularly about? And syntacticians have observed that if you try to do same kind of extraction out of a relative clause, like the author who wrote regularly about something arrived, you would end up with, what did the author who wrote regularly about arrive? Which is a very bad sentence. I hope you think so too. Okay, so the generalization is that you can't really form a long distance dependency across a relative clause boundary. Okay, and then what does that imply for the real-time sentence analysis mechanism? Well, okay, so when you get the double phrase, you need to search for a gap position. But as soon as you hit this relative clause region, the processor must think, okay, this is this island domain, so I'm just going to skip through this and then look for the gap position afterwards. Okay, so this is like a representationally opaque domain in which the processor just ignores any kind of long-distance dependency formation process. Okay, so we just embedded those intransitive and transitive verbs inside those islands. Okay, so that should just give us like a pure lexical access time for these verbs that has nothing to do with filler gap dependency completion. Okay, and so the blue bars are what you saw before, and then the red bars are the island conditions, right? And then here you don't see any difference between the two. So that suggests that the difference you saw earlier between intransitive and intransitive was not due to the lexical factors. All right. Okay. So just summarizing so far, this type of evidence suggests that the processor is really predictively building structures ahead of rich lexical information like verbs, for example. Okay? This again highlights that the parser is very willing to take risks, right? I mean, the parser could have just waited one more word and just get the verb, right? Before actually generating such a gap analysis, but that doesn't seem to stop them, okay? And again, looking at this kind of long-distance dependency processing, we can see that real-time computation could be actually ordered in different ways. Here specifically, we saw that syntactic processes seem to be happening before interpretations could be assigned, which seems pretty reasonable. Okay, but we couldn't do that when we were looking at local dependencies like the boy ate the cake. Okay, and that becomes important in understanding the patterns of sentence revision behaviors in the second part. Okay. Okay, so as I said, when you do this kind of predictions, any of these predictions could be actually wrong. Okay, so now what we're going to try to do is to see what happens when those predictions turn out to be wrong. Okay, and then for this purpose, it's very useful to look at children. Okay, so adults are oftentimes really quick in doing all kinds of processes, and it might be difficult for us to observe what's actually happening, but children tend to show much more dramatic behaviors, especially when they fail to analyze certain sentences. Okay, so for example, there's this famous observation called the kindergarten path phenomenon, in which children seem to be really struggling to revise sentences. Okay, so this was a study by John Truswell and colleagues. So this was an act-out task. So children had to listen to instructions and move objects in the scene. Okay, and they presented. So yeah, in the scene there was a frog that was sitting on the napkin. There's an empty napkin. There's a box, and there's another distractor toy. And they heard instructions like put the frog on the napkin in the box. Okay. So when you hear this sentence, there's a temporary ambiguity. Okay. This PP on the napkin could be specifying the destination for just putting the frog, or it could be indicating where the frog is. Or in other words, it could be a noun phrase modifier, right? And then when you get the second PP in the box, you kind of have to reanalyze this. And then eye movement data has shown that the adults and children both sort of interpret this as a destination. So as soon as they hear put the frog on the napkin, they just look towards this empty napkin. Okay, but when they hear in the box, right, this has to be the ultimate destination. So they need to revise this interpretation to an NP modifier interpretation. But it's been shown that when you look at the active performance of children, children just seem to get stuck on the initial destination interpretation. So they just move the frog to the empty napkin. Okay, whereas adults never do that. All right. Adults just move the frog to the empty box. Yeah.
Do they ignore it in the box? Or do they then take it as a second
children?
destination or something?
Yeah, so there are various patterns. So some just ignore the second one. Some actually do two movements. So they just move the frog to the empty napkin and then into the box. But in that case, it's as if they just reanalyze the sentence as something like put the frog on the napkin and then in the box. Okay. So yeah, there were these two kinds of errors. But yeah, in either way, right, it seems that they just can't get rid of the initial destination analysis of on the napkin. Okay. But so far, the kindergarten path effects have been studied in very few sentential contexts, namely just that, put the frog on the napkin sentence. And then they all involved an act-out task. And then, so it's possible that maybe what's difficult is the inhibition of the motor planning, right? So maybe they already plan to just move their arms from, to reach out to the frog and move it to the napkin as soon as they heard put the frog on the napkin. And maybe that's what's difficult to revise, right? So what we try to do is to go beyond that, right? By looking at different properties of sentence revision mechanisms. So it's been shown in adult research that not all garden path sentences are created equal. So some are difficult, some are easier. And by looking at the distribution of these difficulties in garden path sentences, we can sort of understand better about what's actually causing the difficulties. Okay, so I'm going to focus on the nature of representations, in other words, syntax and semantics, right, in order to shed light on this question. Okay, so the construction that I looked at is something like, where did Emily tell someone that she hurt herself? Okay, and then this involves an ambiguity. And the reason why I looked at this was because there were three nice features. First, 5-year-olds are known to have pretty sophisticated grammatical knowledge with respect to WH constructions like this. So whatever non-adult-like behavior you see in this domain is not due to like immature linguistic knowledge. And then WH processing, as we saw in the earlier part of this talk, is a very good testing ground for incrementality in revision processes. And different types of error signals can be manipulated, be presented in this construction. But I'll explain the second and third point in more detail. Okay, so if you have a sentence like this, where did Emily tell someone that she hurt herself? You notice that it's ambiguous because you can assign a main clause interpretation in which you would be answering where the telling event happened. You could also answer where the hurting event happened, which I would call an embedded clause interpretation, right? And then if it's the case that children and adults, right, associate the WH phrase with the first thematic position, and then also sort of avoid reanalysis processes in general, then generally we should see preference for main clause interpretation, right? And what's nice about this is that, again, when you go to a language like Japanese, where the order of the verbs is exactly the opposite of English, we should predict a different pattern, right? Because the first verb that comes up in the sentence is the embedded clause, right? And therefore, we would predict that children and adults would prefer embedded clause association. And then the fact that this gap creation happens in the embedded clause domain is very useful for us because main clause verb domain is very limited in the choice of verbs we can use, but the embedded clause domain is much more easy to manipulate. So we're going to present different kinds of error signals in this embedded clause region. So, okay, so the first set of studies are about, do we actually incrementally attach double H phrase? Yeah, yes?
If you go back to the example,
Mm-hmm.
but no one go back just to the original sentences that ended with the question.
Yeah.
You understand? So there is some imbalance, though. I don't know how one controls for this.
Mm-hmm.
Where it has to do with the notion of hurting, right? So in other words, how relevant is it in real life? Tells something, the location where you go with someone versus where it hurts you.
Yeah, that's a good. Mm-hmm.
It's not balanced.
Yeah.
It's balanced, but maybe it is balanced.
Right, that's a good concern. And then what we try to do was to present stories in which both interpretations are equally feasible. Okay, so yeah, I'm going to get back to that point. Okay?
I also have a question, sorry, about this example. The Japanese sentence really is a garden path sentence. In other words, if you left out the last word, you could put a question mark right there and it would be inverted.
Yeah. Okay, so here, what I did was I actually omitted the subject of the embedded clause.
Yeah.
Right. So actually, at this point, you don't know that they're biclausal sentences.
Right.
So only at the point of processing the complementizer, you know that there has to be another clause.
So, okay, right. So you'd have to drop the complementizer, the last two words.
Right. Yeah. At that point, you are sure, yeah, that there are two clauses.
Okay.
Yeah.
Up until then, it's a garden path.
Right. Right. Okay. So so yeah, the task that we used was a question after story experiment. So it's a very child-friendly task because what they do is just listen to stories and then answer questions about what happened in the story. Okay? So here's a sample story. This is a story about Emily who likes to play outdoors. And one day she decided to just play on the swing set. And she was swinging really high up. And then she jumped off the swing set, but she balanced herself really well, so she didn't hurt herself. Okay? But that was not thrilling enough for her, so she decided to climb a really tall tree. And she went up really high in the tree, and then one of the branches broke, so she fell off the tree and hurt herself. Okay. But she was a really tough girl, so she didn't cry at all, and she felt very proud of herself. So she decided to go look for her friend and then brag about how strong she is. Okay. So she went to the library and found a friend, but before Emily got to talk to her, the librarian came out and then told Emily to be quiet because you can't talk in the library. But fortunately, there was a swimming pool right outside the library where Emily can just talk as much as she wants. Okay. So she found her friends and then said to them, I fell off the tree and hurt herself, but I didn't cry at all. And Emily's friends were really impressed. Okay? Question. Where did Emily tell someone that she hurt herself? Okay, so you can see that you can answer pool, which would be the main clause interpretation. You could also answer tree, and then that would be the embedded clause interpretation, right? And we ordered we balanced the order of saying events and doing events, so that there's no like story ordering bias. Okay, all right. So for the main clause verb, we had tell someone and say to someone. And then, sort of just as we predicted, both adults and children really strongly prefer main clause attachment. Okay, they just answer pool most of the time. Okay, but yeah, at this point you might say, well, this might be just about something about I don't know story biases that we had in the stories. So we can address this concern by looking at Japanese, right? So here we used exactly the same stories, but the only difference is that the sentences are in Japanese, right? And then recall that the first verb you hear in the sentence is embedded clause verb. Okay, and here both adults and children seem to strongly prefer the embedded clause interpretation. So they, like, above 90% of the time, they just answer tree. Okay, so that suggests that the preference we found in English was not due to the story biases. Okay, so the fact that both in English and Japanese they prefer the first verb attachment suggests that this really has something to do with how we are assigning interpretations to the sentences in real time. Okay, so now using this property, we sort of try to block these predictive processes. Okay, so what we did first using Japanese was to sort of fill the gap for them. Okay, so if they really analyzed where as coming from this gap position, they should be surprised when they hear the actual overt PP that's associated with this verb. Okay, so it's like saying, where did Emily tell someone that she hurt herself at the tree in English, except that the hurt herself at the tree comes first before you hear told. All right, so in this context, I mean, this should force everyone to just reattach the WH phrase to the main clause verb. But if they actually fail at the sentence revision process, then they should still answer tree, even though that's what you hear in the sentence. Okay, and then what we found was, first of all, if you look at the red bar, adults, I mean, most of the time, they just answer pull. So that shows that they can successfully reanalyze the sentence. Whereas children seem to be answering tree, even though they heard tree right there in the sentence. Okay, and then if you look at the proportion in the of tree response in filled gap and ambiguous conditions, they're really roughly the same. Okay, so despite the presence of this overt PP, they still answer this embedded clause response, and this is sort of a novel kindergarten path effect, right, involving WH dependencies, and there was no act-out component to this task. So it seems that this kindergarten path phenomena is a much more general phenomenon than people have thought before. Okay, so we try to present different kind of error signal to sort of make children perform better. Okay, so what we did then is to sort of manipulate this selectional restriction of the verb with respect to the WH phrase. Okay, so in the Japanese WH phrase, there's a postposition at attached to the WH phrase, and then we presented verbs like went, for example, which is a directional verb, and then verbs like went is incompatible with postpositions like at. And then we try to see if that might lead children to revise the sentence. And notice that in a totally different structural domain, people have found that children are willing to sort of change, coerce like a non-adult like interpretation here. So it's possible that they still get stuck in the embedded clause analysis here. Okay, but we found that we don't have any adult data here, but the 5-year-old children were actually pretty good at answering pull, getting the main clause response in this condition, suggesting that they were actually pretty good at using this semantic, lexical semantic information between the verb and the WH phrase to control the WH attachment process. Okay, so summarizing so far, the filled gap error signal led to no recovery, but the verb semantic information led to a successful recovery. Okay, so it's not so clear what's actually happening. I mean, one way to look at this is that maybe the syntactic clash that's happening here is not so worrisome for children, because if you just sort of ignore this error signal, you will still end up with a correct interpretation, or like a licit interpretation, right? You can just associate where with her, and then that gives you a fine interpretation. Whereas if you just leave the WH phrase inside the embedded clause, you just can't assign any interpretation, because where and went, where at and went are just simply incompatible, right? So this suggests that maybe interpretation has a higher premium for determining sentence processing behaviors. Okay. So then the next question is, well, what happens if such error signals appear after both structures and interpretations are assigned to the WH dependencies. Okay? So we looked at what happens in French, which really has the same properties as English. We did this in French because I was in Geneva, and that was a French-speaking city. So you have the French sentence like this, which is really the same as English, right? Where Emily has told that she sells hurt. Okay. So we just inserted a filled gap in the main clause region, like where did Emily tell or explain at the pool that she hurt herself. Okay. And then notice that this PP is coming after the verb, unlike in Japanese, right? In other words, you can already assign the structures and interpretations to these filler gap dependencies before you heard à la piscine, that's the at the pool. Okay? And then what we found was that, sorry, this is now plotting the proportional first verb attachment. Okay, so Japanese people are going for the embedded clause interpretation here, right? This is ambiguous condition, right? And the French speakers are going for the main clause interpretation, which is the same as English, right? But when you get to the filled gap condition, this is the proportion of successful revision, okay? So again, children are bad at revising. So in French, they answer pool. In Japanese, they answer tree, okay? And then what was interesting was the contrast between French adults and Japanese adults. So Japanese adults were almost 100% correct in revising this initial analysis, but French adults were actually kind of stuck on the first analysis. And then many of them actually answered pool, even though they heard, where did Emily explain at the pool that she hurt herself? Okay? So that suggests that maybe the timing of information that unfolds during the course of sentence processing really matters, right? We saw that in French, the error signal comes after the verb. Therefore, you had already committed to the syntactic structures and the interpretations of that filler gap dependencies. And maybe that's what's causing larger difficulty for French adults. Okay? Okay? Right. And that suggests that, I mean, one implication of this is that, as I told you earlier, in a sentence like, while Anna dressed, the baby spit up on the bed, that's known to be difficult for English adults. And maybe this is because of this interpretive commitment that you make at the point of processing, dress the baby. Okay. But anyway, but here again, you see that drawing a sort of a sharp distinction between syntactic processes and interpretive processes allows us to understand what kind of syntactic environments cause reanalysis difficulties. Okay? All right. How much time do I have? 10 more? Okay. So let me just briefly go through this. This is still preliminary work. But I think this kind of predictive behaviors in children might actually affect how language acquisition happens as well. Okay. So the point is a very simple one. I mean, if you make risky predictive decisions, you're going to be wrong. And if children are bad at revising their analysis, then based on that wrong analysis, they might actually learn wrong things, right? So in the critical sentence that we've been looking at, right, English allows both main clause interpretation and embedded clause interpretations, right? And if that's the case, for children learning WH dependencies, they would expect that there should be evidence for both main clause and embedded clause interpretations in the input, right? I mean, it's not going to be actually 50-50, but there has to be evidence for both kinds of interpretations in the input, right? And this is critical because there is a language like Russian where you present the literal translation of the sentence, and then they can grammatically only entertain the main clause interpretation. Okay, so there's a cross-linguistic difference. Right? And then, I mean, if you're learning Russian, then you would certainly expect that, I mean, most of the sentences should only yield evidence for main clause interpretation, right? But what's troublesome here is that we saw experimentally, children actually have a pretty strong main clause attachment bias. In other words, even if the intended sort of input distribution from the adults is something like this, it's possible that children's perceptual mechanisms are just skewing the input distribution in such a way that most of the evidence seem to be indicating the presence of main clause interpretation, right? So, in other words, I mean, children need to be doing language hypothesis testing based on what they have integrated into their mind. The question is, does the sort of window into the perception, right? The parsing system itself could be skewing the distribution such that it affects language acquisition processes. Okay, so I mean, if children actually skew the input like this, then you would predict that children might actually learn Russian, but that doesn't happen, right? So it must be the case that the input is somehow structured in such a way that it's child-friendly, right? There must be some evidence, enough evidence for children to learn that there's embedded clause interpretation in English. So in order to look at that, we looked into the distribution of child-directed speech from a childless corpus. So we extracted 150,000 sentences, and then from adults that were recorded in this childless corpus, and then looked at what kind of WH questions are actually present in these utterances. Okay. So in this process, we extracted WH questions and then coded argument versus adjunct. And then we also looked at monoclausal and biclausal sentences. And then non-finite versus finite contexts, because non-finite contexts don't show cross-linguistic difference. So it's only in the finite domain that you see Russian-English distinction, right? So what's important is the adjunct fronting biclausal long-distance finite questions, right? And so in the 150,000 sentences we saw, there were about 15,000 WH questions. And then, so that's roughly 10%. And of all those questions, only 86 of them were involved the target constructions. Okay, so that's very small number. Okay, and then let's just think about how children could be processing those 86 sentences, right? If they actually only sort of actively create a gap at the main clause and don't revise, then those 86 sentences will only support main clause interpretations, so they're going to be misled to think that they're learning Russian, right? But if we look at the fact we observed in our experiments that children can actually use the information or combinatorial information between the WH phrase and the verb and successfully revise their initial attachment, then this may not be actually a problem, right? So we looked at what kind of main clause verbs were present. So as you can see, there were very few main clause verbs. So they were just think was the majority, and then say, tell, know. And these are some actual examples. And then we broke it down in terms of WH type and then the verb type, right? And what you see here is that, I mean, first of all, know, say, tell. All of these things seem to be only forcing main clause interpretation. So, I mean, all of the know sentences were something like, how did you know kind of sentences, okay? And you can't really associate how with the embedded clause predicates, okay? And then tell, we saw experimentally that this favors main clause attachment, right? So the critical one is think, okay? And at this point, the why sentences are actually ambiguous. So if you say, why do you think that John ate the cake, right? You can present evidence for thinking why John ate the cake, or it could be about why John ate the cake. He was hungry, right? But these sentences turn out to be ones in which it is just pragmatically infelicitous to ask WH questions about the main clause predicate. So it's like, how do you think that blah, 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 or where do you think that, okay? So in those cases, it is pragmatically infelicitous to associate these WH phrases with the main clause verb, and therefore, and then that's the kind of information that children can use to revise their initial attachment biases. So these sentences should present unambiguous evidence that embedded clause interpretation is actually possible in English, okay? So by paying attention to these details of child sentence processing mechanisms, I mean, in this case, we found out that this WH domain does not really present a learning problem for children. But you could imagine that there are other cases in which children might be misled to think that they're learning a wrong grammar, right? There was another example, but I'll skip that one. Okay, so conclusion. So I sort of documented like detailed procedures for failure gap computation, okay, by using evidence from long-distance dependency processing in adults and children, okay? And I argue that interpretation-related error signals are very powerful, okay? Whereas completed interpretations seem to be difficult to revise, okay? And I briefly discussed that this kind of predictive mechanism might have a consequence on language learning processes as well, okay? But I guess one thing I can definitely say is that bringing together data from many different languages that have different grammatical properties, and then looking across different kinds of populations who have different psychological constraints can really shed light on how exactly we process and learn languages in real time. Okay? That's all. Yes?
So I guess all these experiments, the sentences were rolled out and they didn't see them.
In the adult experiment, there was a reading study in which they were just seeing the whole text. That's the intransitive versus transitive one. But in the other ones, they were spoken.
So, I mean, is there any difference when they only hear it versus when they see words being displayed as they hear it? Or if you had an experiment where the words appeared, there's no hearing involved, or the words appeared but in different orders. So, like, I'm wondering, like, how much is going on? How much can people figure out if words appear in the sentence, not left or right?
Oh.
I mean, you kind of have to learn how to read it all over again.
Yeah.
And train some new strategies.
Yeah, I don't know any experiments presenting words from sentences from different parts of them. Why are you wondering about this?
It's just interesting. There's no reason why. I mean, the reason why we re-left. I mean, we happen to be people that speak sequentially, you know, but there could be other creatures that could somehow like do things all at once or do things. I don't know.
I see. So yeah.
Actually, here's the reason why. Now I remember. It's because when we're talking about programs, like we have all the sentence available. A lot of times we have the whole sentence available at once, and we can decide what word to process. And so the fact that humans do it the way they do it, maybe that could help us do a better job, and maybe we can do a better job because we have.
I see. Okay, that's interesting. So I mean, I know why people don't present sentences in random order. I mean, that's because we are sort of trying to understand how humans actually do it, right? Yeah, I don't know.
But the first question that Adam's asking, I think, is sort of beyond to go to new experimental paradigms, is when humans are reading and they're tracking their eyes over the sentence, do they in fact move left to right, or do they sometimes see a word? You can imagine that there are some individuals who, when they see a word like put, are going to scan ahead looking for the
I see.
put before they read the intermediate stuff.
Yeah, so, right, I mean, during the eye tracking, usually what people do is that, I mean, they tend to fixate on content words, but if they're like very predictable function words like the, for example, they just tend to skip them. Okay, so, yeah, so if a sentence like this, I mean, they might fixate on city, but they often skip that and the, for example, and then move on to the next content word. And
They're mainly moving left to right unless they guard that.
right, yeah, that's right. When there's some sort of difficulty or, I don't know, they're just getting sleepy or something, right, then they need to regress back and then reread the sentences. But yeah, it's not always the case that whenever there's a gotten path, they need to regress. I mean, sometimes they can just mentally fix the representations in their head without seeing the earlier part of the sentence. So, yeah, I don't know if that has any implications for how computers recognize words and sentences.
I remember the other reason why is because sometimes when I've shown garden path sentences to my wife, I've made the mistake of showing her the sentence, and then she complains that there should have been a comma there.
Oh, yeah, that's true.
And so there are other, like,
Yeah, that's interesting. Yeah, so I mean, even in this context too, I mean, if you already saw that there's about before you process wrote, you know how to process it, so you're not going to be gotten past. And yeah, that's true. If you see the whole sentence, then yeah, that could actually prevent you from gotten past sentences. So yeah, that's interesting. But yeah, I mean, that really shows that depending on the amount of information, you can really control the subsequent sentence processing behaviors, I guess. Okay, that's interesting.
I mean, I guess the other reason is you use Japanese because of the different word order, but it could simulate this with using what Adam says by showing.
Ah, so just present English sentences in a Japanese order?
For example, like kind of verb to.
Yeah, that's interesting. So people have tried that actually with children. So they say like, oh, this is a silly puppet who just says silly things. And then presented to put the frog on the napkin in the box sentence and order like frog on the napkin in the box put or something like that. And then, and then English-speaking children were fine they're good at assigning the NP modifier analysis to that.
I think what Bess is suggesting is a little different. The words on the page are still in left to right order. It's just that they're not revealed from left to right.
Oh, okay. You just, right. Okay. I see. So it just masked and it just sort of bring up different words in non-left-right order.
So that way you're isolating only the temporal, the only variable you have is the temporal variable, so that you're isolating that, and other syntactic factors of Japanese are just causing noise in your signal or anything like that.
So you can imagine blocking garden paths by adding the relative clause last. Right? There's this gap where the relative clause should be. You give them the matrix sentence, and then you insert the relative clause.
Yeah, right. Yeah, that seems reasonable. And yeah, I mean, that's kind of known to happen in the sense that people do sometimes extrapose like embedded clauses, right? And then I guess that you could say that that's like a natural inclination of what you were suggesting. Yeah.
So in the children's red version, how do you neutralize the effect of the prosody?
So we just try to put equal prominence on each of the verbs. So it was like, where did Emily tell someone that she hurt herself? Okay.
Is it read by a person or a machine?
It was read by, I think with children, the experimenter actually set the sentence. So experimenters are trained to just control for the prosody. But when we did this with adults, we just recorded human speech, from people who were trained to do this. And then we just presented the audio recording. I don't know if my prosodic control was actually representative of the...
Can't you just record the experimenters and analyze the prosody after?
Yeah. Yes. Yeah, we could have done that.
I think it would be better to take parsing.
Yeah, right. Yeah, we should probably do this. But, I mean, it's...
Well, the question is whether the prosody that should be used to neutralize the real prosody is the real prosody.
Yeah, right. I mean, this is a good concern, but this is actually... It's pretty well known that children are really bad at using prosodic information. So, I mean, we can, prevent garden pathing, for example, for adults by controlling prosody, but children do not seem to be picking up on these kind of prosodic cues in general. So I don't think the pattern of data from children here was due to prosodic manipulations.
So I'd be worried about this eye-gazing stuff, that the number of characters or the amount of pixels that you can see in one image would depend on things like how many letters are in the word. And when you go to Japanese, that I can imagine you can see more content in one fixation. My impression is that you take a Japanese book and an English book and translation to one another. The Japanese book will have fewer pages. So you can get more content with the same number of pixels.
That's interesting.
Now, I don't know if the eye gazing is based on the number of pixels or if it's based on the amount of content, but I would think it might have to do with pixels.
Well, yeah, I didn't know about this fact that the Japanese books have fewer pages. But I mean, they can do this presumably because they have much more complex characters, like Chinese characters, right?
I mean, I think it takes longer to write Japanese and less time to read.
Yeah, so I mean, you could imagine the reverse of that, which is that actually decomposing the Chinese characters would take longer time.
Right, but Ken, are you worried about what they can see in their peripheral vision or something?
Yeah, that is.
Oh, right. Yeah, so in this context, you're worried that seeing wrote after author.
And even if you change, like compare city and author and wrote, these all have a different number of pixels. Substituted city with some other word that had more pixels.
I see. But I mean, we sort of try to control for the length of sentences across conditions, right? So
But
there
you
might
can't
be.
control this across Japanese.
Oh, yeah. So, yeah, if we go to Japanese, I mean, within Japanese, we're going to try to manipulate the textual or orthographic context.
You were trying
So.
to make some claims about differences between Japanese.
Oh, yeah. So, right, that particular, I mean, in terms of reading behaviors, we do see similarities. So, I sort of skipped over it, but there was a reading time evidence that suggests, again, that Japanese speakers are actively creating a gap inside the embedded clause. And yeah, it's true that they involve completely different orthography and whatnot, but to the extent that at this abstract syntactic structure level, they seem to be doing the same thing. So it's true. I mean, at the level of lexical access, I think you're right to worry about the orthographic organization. Yeah, general reading speed. I mean, that would just affect the entire reading speed, but not like.
But I'm worried about things like a lot of the facts you're talking here are very close to sort of reaction time speeds, and the Japanese are going faster.
Right. Yeah. So I mean, in that case, I mean, if they're faster, they're just going to be faster across the board, right? And then what we're interested in is whether the structural manipulation across different conditions would affect reading time for the particular region we're interested in, right? So I mean, that kind of experimental technique can be used whatever their baseline reading speed is. I mean, it's possible that you might get a floor effect, if that's what you're worried about, because you're so fast.
I think there's certain things you can't, I mean, that is, for example, typing speeds, you can't get more than about a tenth of a second between gestures. To push a button, when I see a light, you're up around half a second. A lot of the things you're doing here must be up pretty close against, human reaction.
Yeah.
You might just be forced to continue,
Right.
A little more precise about the predictions for the actual.
Yeah, that's what I'm not seeing.
Well, I'm just suggesting that I don't have time to think cognitively. So imagine I've got, so that is if the characters of the speed are so fast, then I could imagine just something like n-grams.
But what would you actually predict for this fixation?
Well,
random, flat,
I mean, all I'm trying to say is that I think that if you speed things up and you hit the floor of what people can, what your reaction times are, you can't think about it. So you couldn't involve anything in all.
Yeah, right. I mean, humans they can control their reading processes, right? So if they actually experience difficulties, they're going to slow down. And then that's sort of what we're measuring.
So you're saying the speeds that you're doing. So my prediction is that some of the things you're doing are up in the range in which people can't make cognitive decisions. Say, for example, when I'm typing THE, I can't stop. Start recording.
Oh, but I mean, you would slow down if you have other things to worry about.
You can clear the pipeline and start over.
Okay. Well, I mean, I think it's an empirical question, but I think it's an empirical question.
So the question really is, what speeds are we talking about here? Are we at speeds where people can actually think?
Yes.
So these things take on the order of seconds to process, not even when you're reading Japanese. For an adult to read this in Japanese, you would be talking about time.
Yeah, I mean, so this is like within 300 millisecond effect,
What is the
right?
300 millisecond event?
This is a single fixation, average fixation duration on the verb region. This is from English.
Pretty slow reading time.
No, I mean, fixation duration can range from 100 to 600 milliseconds.
Read a paragraph or something. Would it take 300 milliseconds per content word?
Yeah, on average, there's research on this. So on average, people take about 250 milliseconds per fixation to access lexical information. So this is...
To read a whole paragraph, it would take a quarter of a second per content word.
Yeah, it depends on the length of the paragraph. Yeah, sure.
Actually, I thought people can read much faster than a radio announcer can
say this?
Yeah, look, it really depends on the control you want to put into the reading process. I mean, you can try to skim by skipping a lot of words, or you can just try to actually fixate on many content words to read carefully. So this is really a human factor. You can just control this process pretty flexibly, okay? Which is why it's interesting to look at how structural differences can cause slowdown processes, right? So no matter how fast you are in general, we expect that certain structural properties would slow people down, and that's what we're measuring. But anyway, I think it's an empirical question. So. Yes.
Did you redo the child's corpus analysis that you talked about in Japanese?
Oh no.
Is that updated available?
I mean, I would expect that so yeah, I mean, the Japanese corpora are small, but so first of all, the structure that we were using in Japanese, in which the WH phrase was fronted, that's very rare in natural speech. So yeah, I would expect that there wouldn't be much data that's relevant for this. Why are you wondering?
I was just wondering if you found the shorter dependencies being more common in Japanese too, even though they'd be associated with
I see. Yeah, we don't have evidence for this. I mean, you could imagine looking at like Japanese newspapers and magazines and see if Japanese adults actually produce shorter dependencies too.
So, housekeeping announcement. We're all invited to lunch on the first floor. Second, there's a sign-up sheet that went out. If you need to sign up and you get it, go for it. And last thing is your sign up.
Thank you.